I think we are good to go for the next session.
Please let me know if my screen is visible.
Yes, ma'am, your screen is visible.
Okay, thank you. Let me know when I can start.
Deep Shwan, sir?
Yes, Shumi sir.
Yeah, please take control from here.
Thank you, Shumi sir. Good evening, everyone present in this Auto FDP program. It fills me with immense delight to welcome you all at the fourth day, session 8 of Auto Online 6 Days FDP on Quantum Edge Intelligence, organized by CSE Department MCKVIE. A special space where we pause our
Deep
own
Deep
daily
Shwan, sir?
routines.
Deep Shwan,
Yes,
sir?
yes.
Please wait a minute. Ma'am, can you please switch on your camera if possible?
Yeah, sure.
Thank you. Sir, you can get it.
Okay. Again, I'm starting from the first. Good evening, everyone. It fills me with immense delight to welcome you all at the fourth day, session 8 of Portal Online 6 Days FDP on Quantum Age Intelligence, organized by CSE Department MCKVIE. A special space where we pause from our daily routines to engage, learn, and grow together as a community of educators. Today feels especially rewarding for we are joined by Dr. Debatri Chatterjee, Senior Scientist, TCS Research, Tata Consultancy Services Limited, Kolkata, India, whose presence among us is truly a privilege. Dr. Debatri Chatterjee has completed her MTech in Radio Physics and in Electronics from University of Calcutta and Doctor of Philosophy in Computer Science and Engineering from Jadavpur University. She has more than 20 years of industry experience. Currently, she is working as a senior scientist in TCS Research. Her area of work is physiological signal processing for human cognition and behavior analysis. She holds more than 30 granted patents, Indian, US, and UK, and have published over 100 papers in various prestigious Tier 1 conferences. She is also an external member of Innovation Council of Alia University and advisor of Center of Excellence for GNH Studies and Research at Amos University. We are indeed fortunate to have Dr. Debatri Chatterjee with us today speaking on IoT sensor at edge, a theme that I am certain will broaden our perspectives and enrich our discussions. So let us extend our warmest welcome to our esteemed guest, Dr. Debatri Chatterjee. Madam, the session is yours.
Thank you, Dr. Dev. Thanks for this lovely introduction. So I'll start. I'm just switching off my video because there is some issue with my internet.
Yes, ma'am, no issue.
Okay. So yeah, is my screen visible?
Yes, it is.
Yeah. So thank you, everyone. So we will just go through the things. We'll start with the IoT sensors at edge. And as Dr. Dev said, my area of research is mostly focused on human behavior sensing and human cognition sensing using various physiological signals. So how these signals or how these sensors are used at edge. So that will be our discussion point today. And during this presentation, at any point, if you have any question, please feel free to stop me and ask. So with that, we'll start. So this is our today's agenda. So what I have thought that we will start discussing about what is age, the advantages and disadvantages of edge computing, then edge computing architecture, and some of the application use cases where this edge computing is used. After that, we will move on to the IoT sensors at edge, and I will mainly focus on the IoT sensors that are used for human sensing. Now, when we talk about human sensing, first thing we need to understand is what is human sensing and what are the different types of human sensing and how these assessments of human behavior and human cognition are done. So we will discuss that. And then we will discuss the physiological basis of that human behavior. And of course, I will not go into much details of biology, only a top level view of the physiological basis of our behavior, and then physiological sensing based behavior analysis, how it can be done. And then I will conclude with some of the works that we are doing in TCS using these physiological sensor signals. So with that, I will start with edge computing. So edge computing, it is a type of distributed computing where multiple interconnected computers or node, they work together to achieve a common goal. So here the machines are distributed over different locations, and the tasks are also distributed across different machines. Now, this is done mostly to improve the performance and the reliability and scalability. Say, for example, we have a large number of cameras, and we are trying to uh, see the CCTV footage of a building. So there are different cameras which are installed in different sections of the building, and all those data are being transferred into a central server system. So this is a kind of distributed computing system. Now, when we talk about distributed computing system, so the basic components of the distributed computing system are two. So one is the sensor, which is used for collecting the data. And then there is a central cloud system where these sensors, they collect data and they send the data to a central cloud system for processing, analysis, and storage. And then based on the data, they might generate an alert or do some work. Now, there are certain issues with this kind of distributed computing system. Though we say it is performance is better, reliability is better, scalability is there, but still the issues are like these are very slow processing, because there is a high bandwidth requirement and heavy load on the server, and also there are synchronization issues because different devices are connected to the cloud. Now, if we go back to the CCTV camera scenario in the building, now here suppose there are different dozens of high resolution video cameras. Now these cameras, they output or generate a raw video signal, and these signals are continuously sent to the cloud server. Now on the cloud server, the signals are put through a motion detection system or application to ensure that the clips which contain the motions, any kind of motion, those are stored. Now this means this system, it requires a constant and significant strain on the internet infrastructure, because we are continuously transmitting high volume of footage to the cloud server, and also these cloud server, they had to process a large number or a large amount of data to identify the clips which contain the motions. So to solve these kind of problems or these high bandwidth requirements and all, we go for edge computing, where edge computing, what we do, it is just a distributed computing architecture, but instead of sending the data directly to the cloud server, some of the data is processed near its source, or it is at the network's edge, rather than relying on the central server. So we are processing the data closer to where it is generated. That is in the sensor level, or it is very close to the sensor level. So the advantages that we get is, now we don't have to transmit all the raw data to the server. So it reduces the bandwidth requirement, less data has to be transferred. It reduces the latency also, because earlier we had to send all the raw data to the central server, and then central server do the processing and generates the alert. Now, since some of the processing has been done at the sensor level, or very close to the network, or the edge, at the edge of the network, so it reduces the latency, and less server resources are required, so less data has to be stored. And it also helps in real time processing of the application, since we don't have to continuously communicate with the central server. And obviously, since infrastructural requirement is less, so it reduces the cost. Now, if we go to the actual edge computing architecture, this is the basis of a basic edge computing architecture, where there are three different layers: cloud layer, edge layer, and device layer. Now, device layer is the lowermost layer, which contains all the devices. So it can be any small device, like our mobile phone, or it can be a very high computing device, like a computer, laptop. It can be a autonomous car, or anything like that. So these devices, they actually collect the data, they capture the data, and in some cases they also do some kind of processing, a very negligible amount of data analytics or processing. Then comes the edge layer, which is the second layer that contains edge servers, or edge nodes, and they mostly do all the data processing, data reduction, data caching, buffering, control, all the control responses that needs to be sent, that is done. And then finally, that data is transferred to the cloud layer or cloud server for storage, mostly for storage. So this edge layer, so data that can be processed, so data can be processed either in the device layer, or mostly the processing is done in the edge layer, and then the final data is transferred to the cloud layer. Now, if we again come back to our CCTV scenario, so earlier for distributed computing, what we were doing, we were collecting, say, video feed from dozens of cameras, high resolution cameras, and then we were directly sending it to the cloud layer for processing. Now, what we can do, we can collect the data in the device layer using all those high resolution cameras, and then we send the data into this edge layer, where they might select the frames or the part of the data which contains the motion. And then this, if some alert needs to be generated, they do that, and finally the storing is done in the cloud server. So that is how we go from distributed computing to edge computing. Now, having said that, it's not that always edge computing is very advantageous. It also has some kind of limitations, because if there is a device failure in any of the edge devices, or in edge node, if there is a failure of any device, then it disrupts the whole architecture. So that is one issue. Then the second is limited capability, because many edge devices, they do not have the power needed to do the complex computing. Usually they have very less power, and less memory, and less storage capacity, compared to a centralized cloud data center. Say a cell phone, for example. It is uh, it may be a powerful device, and whatever powerful cell phone you are using, it is still less, its power, its memory is still less compared to any mid-range laptop, or when it comes to power. So that kind of limited capability is another issue. The third issue is the network connectivity. So in this type of edge architecture, we have a dependency on the connectivity in the internet flow. So for all devices and between all nodes, and then from node to server. So it requires a continuous network connectivity, and if that connectivity is disrupted, that disrupt the whole architecture. Then there is a cost issue, because initial setup and maintenance cost of the distributed edge system is high compared to clouds, because in this case we also have to install this middle layer, which is the edge layer, and that contains to some extent high power consuming edge devices. And another issue that is faced in case of edge computing architecture is the data consistency. Now, since data is processed locally on multiple edge devices or edge nodes, so ensuring data consistency across the entire system, one in system can, it might combine 5, 10, 15 edge servers. So, ensuring data consistency across all these servers is difficult. And also syncing back when we are from cloud, when we are sending the data back to the edge server, then syncing the data to that particular type of edge node or server, that is also an issue. Now, having said that, so but uh, now that we see that yes, edge computing, it has some advantages and some disadvantages, but there are certain applications where these edge devices are used, and they prove to be very good. So some of these possibilities are like, as I was saying, the security system, security monitoring system, then IoT devices or smart devices that are connected to internet, then autonomous car or autonomous vehicles, which actually need to react in real time if if the driver is sleeping, or if there is some issue with the, I mean, there is some traffic congestion or anything, then the alert needs to be sent at real time. So in those kind of scenarios, edge computing is very useful. Another thing is hospital and healthcare, where we gather or collect patients' data, maybe patient vital sign monitoring. And in that case, also, we need to send the alert in real time. So if his heart is failing, or if his, I mean, heartbeat is not there, so that alert has to be sent in real time. So in those cases also, this is very good. Then in smart homes and smart cities, where traffic management or analyzing the videos and sensor data at traffic intersections, or the smart grids, which are used for energy management and detecting faults in real time. So in those cases also, it is very useful. Then in retail, in-store analytics and personalizing the marketing or product recommendation. So in those cases, edge computing is also very good. And the last but not the least is the video conferencing. Now, let's move on to the IoT sensors at edge. Now, IoT sensors are the devices that collect data from physical environment, like temperature data, humidity data, motion data, or anything. So these IoT system, they they work effectively with smooth data transfer, real-time monitoring, and intelligent response. So connectivity through edge or cloud devices is crucial. So instead of sending all the data, all these IoT data to the cloud, what we can do is we can do some of the processing at the sensor level or at the nearby edge devices, and that will reduce the latency and bandwidth requirements. Say, for example, the temperature sensor data in a factory setting. Now, instead of sending all the raw temperature data continuously to cloud, we can process the data locally, and then if the temperature exceeds, say, certain threshold value, then it can send the alert to the cloud. So that kind of IoT sensors are used for at the edge. Now, edge computing offers a range of benefits to IoT sensors like improved efficiency, reliability, security. Edge devices can continue to operate even if there is a loss of connectivity to the cloud. So even if you cannot store it, at least you can send the alerts, which is very important for uh, monitoring, I mean, healthcare monitoring, or any smart grid monitoring, or any temperature monitoring in a factory settings. In those cases, it is very important. So, enhanced security of IoT systems by processing sensitive data locally, especially as Dr. Muhua ma'am was also saying that health data, there are certain privacy issues. We cannot store the data, we have to anonymize it, and all those things are there. So instead of sending all the data to the server, we can process it locally, and that will ensure the security of the sensitive data. Now, based on different types of IoT data or IoT sensors that are used, we can broadly classify the IoT sensors into 4 categories. So first category is the environmental sensors. So environmental sensors like temperature sensor, air quality sensor, gas sensor, light sensor, water level sensor. So these are the sensors which we use for sensing our environment. Then there is motion or proximity sensors, which is like motion sensors, proximity sensors, occupancy sensors, that kind of thing. And then there are industrial sensors like vibration sensor, current monitoring sensor, pressure sensor, infrared sensors. And finally, the wearable sensors, which we usually put on humans for detecting various physiological signals like heart rate monitor, galvanic skin response, breathing sensor, blood oxygen sensors, like that. Now, let's move on to the IoT sensors that we used for human behavior sensing. Now, before going into the sensor details, first let us understand what is human sensing. So, human sensing is the ability of a system to recognize and interpret human presence, human actions, emotions, or any physiological state. So, it is a science that encompasses a range of technologies to observe and analyze a human. Now, extraction of information about the people present in an environment, so that instruction can give mostly two things. So when we talk about human sensing, we usually talk about detection of human behavior and human cognition. Now, let's understand what is the difference between human behavior and the cognition. Human behavior is the way we respond to our external stimuli or our external environment. So that can be a visual response or a visual behavior, an audio behavior, a body gesture. So these are all human behaviors. And then there is cognitions, which are basically mental processes, different types of mental processes that allow us to process the world outside us. So like perception, attention, memory, cognition, so anxiety, emotion. So those are the cognition related detection. So when we talk about human sensing, we have to detect either human behavior or human cognition. So the either the human response or the mental process underlying that response, or the process that generates that response, which is the behavior. So why it is important? Now, human sensing and machine sensing. Machine sensing is not that critical because if you have designed say any type of machine, it is say a washing machine, it is supposed to behave in a same way. If you have designed or developed 100 washing machines, so they are supposed to behave or act in a same way. But human, we behave differently. Now there are different factors which actually define how we behave. So first is the psychological factors. Psychological factors, like first thing that comes is the personality traits. So these are there are various methods which or various scales which are used for measuring the personality traits, like big 5 personality trait or 16 pf. So they actually indicate the factors like whether the person is introvert or he is extrovert or he is aggressive, or how he's how the way he behaves, or his work style, his decision making styles, his problem solving skills. So all these come under the personality traits, and these personality traits are different from different individual. Now say if you are using a big 5 personality trait indicator, that will also say, it cannot say that yes you are very aggressive or you are not aggressive. No, they will say you are 60% aggressive, 30% introvert, like that. So this also, it is not like we are classifying people or his personality trait into 4 categories and then we can expect 4 types of behaviors. No, each individual is different because there are other factors. Personality trait is not the only one. The second thing is like cognitive processes, our perception, our past learnings, our attention. uh, these these things are our underlying mental processes. They actually influence our behavior a lot. The way we perceive something, that define our behavior. Say for example, if we perceive something as a threat, then we act defensively, we become anxious. Now this perception of threat, that is different for different individual. So if I am fearful of dogs, I will see a dog and I will be anxious, I will be fearful, I will be defensive. But that doesn't mean that every human being is fearful of dog. So these perception, the way we perceive our external world or our uh, environment, that is different for different individual. Then the third one is emotional influence. Our emotional state plays a very important role in our behavior. If we are already stressed, then we get agitated very easily. And if we are calm, we are happy, then we don't get agitated so easily. If we are sad, then we are not attentive. So these kind of emotional influences are also there when we are sensing a human. Then the fourth one is the psychological development. Now from our infancy to adulthood, we go through different situations. We learn, we adopt accordingly, and it shapes the person that we are today. Our social norms, our environment, that plays a very major role in shaping our psychological development. So we behave and act based on that belief system. So what we have learned, what we have learned from our infancy to the adulthood. So those kind of things, how we feel, how we relate to others, so those psychological development is very important and a differentiating factor. Then there are neurological factors which are like genes and our brains. Our brain is everything. So the genes we inherit from our parents. So these are like the blueprints of our behavior, our personality, our cognitive abilities. They largely are inherited from our parents. But they actually but these are not everything. So a son of a doctor is not always a doctor. So a son of an artist or a painter is not always a painter. So genes or genetic factors, they represent the potential or the nature, and then the environment, our perception, our psychological development, our personality trait, those are the environment that defines how we use those potentials. So those are like how they are nurtured. And then there are hormonal influences which changes our behavior, and then environmental factors like life experiences, uh, cultural backgrounds and norms, and the current context and state. As I was saying, if I'm very stressed, then I get agitated very easily. If I'm sad, then I am not able to concentrate, but that does not mean that my concentration power is low. My current state is like that, my current context is like that, that I'm sad, that's why I'm not able to concentrate. So current context and state. So when we are actually sensing a human, they all these factors comes into play. So that is why this human sensing is very critical, and it is very difficult to define or to generate or to develop a generic model that will work well for all individual. Usually for all these human sensing thing, if you train a model with a personal data, a subject specific data, subject specific models, they work really well. But when we train a system using my data and try to test it with another on another individual, that time they usually don't perform well. So with all these things, now when we say about human behavior, there are mostly or basically three types of behavior that provide a framework for understanding the human interaction through observable uh, actions. So like first thing is can be a physical action, any type of physical movement, that is what we do. Then non-verbal cues like our body language, our body posture, our facial expressions, and these are all visual behaviors. Then there are auditory behaviors like the language, what we say, the way we speak, the words we choose. Then the vocal delivery like our pitch, our volume, our pace, our emphasis, and also the emotions that gets reflected in our speech. So those are like auditory behavior. So when we are talking about human behavior sensing, either it will be any kind of visual behavior or an auditory behavior. Now when we do a human behavior analysis, broadly there are two ways we can do this analysis. So just a moment. So either it can be a qualitative method or it can be a quantitative method. So qualitative methods are like when we are saying how the person is behaving and why the person is behaving like that. And quantitative is when we quantify his behavior. So how much? So that is the quantitative research. So in mostly psychologists or psychiatrists, they use this qualitative research because that is the most ancient and most trusted, most proved method. So there are different kinds of qualitative research methods like observations. Observations are like when we let people uh, work or let people be in their own environment, and the psychologists, they just observe them from a distance. Then there are interviews. So interviews where the psychologist or the trained professionals, they asked some questions. So this can be a open-ended question, or it can be a closed yes no kind of question. It can be a in-depth interview or a focus group kind of interview. that is there. And then there are surveys and questionnaires. So surveys and questionnaires, these are most widely used, and for different kind of human behavior assessment, human cognition assessment, psychologists, they use different kinds of surveys and questionnaires. These are all standard psychological questionnaires. And I mean, these surveys and questionnaires, they were developed using thousands or 10,000 people's data, and they are all called norm reference data. So this is, they usually they don't differ, but if you see in the, I mean, when the psychologists they also use it, they also say that it is with that amount of, say, certain amount of probability the person is like that. They also cannot say that it is, yes, 100% it is, the person is like that. So that problem is there. Then there is quantitative research, where we have mostly three methods. There are certain psychometric or standard tests, and then there are some performance based measures, and there are physiological measures, that is the physiological sensor based method measures. So let's go to one by one. So first, let's talk about the qualitative measures. So these are like observations, interviews, surveys, and self-report questionnaires. So observations like watching and recording the behaviors, the action, reaction, body language as they occur naturally, to understand the specific characteristics of an individual or group or a setting. Now, it helps to derive a behavioral pattern and predict the behavior in future. And these kind of observations, these are mostly useful for children, where they cannot manipulate others, or they usually be like their own in their own environment. So these kind of observations are mostly used for studying children. And the advantages being, these are easiest, straightforward methods. It helps to develop the hypothesis regarding a personality trait and human behavior. But the limitation, the, I mean, most important limitation is it needs an expert or experimenter to so more it's prone to bias. So one individual or one experimenter cannot uh, do the observation for 10,000, 50,000, 60,000 children. So you have to employ, say, one experimenter for 50, for observing 50 children. And like that, you have 10, 1,500 observers. So there is a subject to subject or observer to observer bias, because whatever we are observing, that also depend upon our own perception of the world. So I might feel something or some behavior as aggressive, but the other one might say, no, it is not that aggressive. It is not good, but it is not that aggressive. So that kind of subject to subject bias is always there when we use multiple experimenters. And again, these are very slow, expensive, and labor intensive method. And also there is a lack of reliability, because sample size has to be small. We cannot study 60,000 or 1 lakh children to derive a behavior. So sample size is obviously small, and not all the cases can be covered. Then comes the interviews, which can be either an open-ended interview or structured questions that are asked to understand the human psychology. Now, the advantages being, these are very easy to replicate. It takes relatively less time for implementation, but the structured ones are less flexible, because it cannot say why. It can only say, are you, I mean, the question is like, are you anxious when you see something is falling, or something is if you see a dog, the person will say yes. So but why he is fearful of dog, whether it is any past bitter experience, or he is fearful of any four-legged animal, that why cannot be answered using this kind of interviews. And the open-ended interviews are like they are very time consuming. And then there is the surveys and self-report questionnaires. There are a set of or pattern of questions which are used to understand the behavior, perception, traits, and abilities. These are very standard questionnaires. Different kind of questionnaires are there for checking the anxiety. Sometimes psychologists, when we go to a psychologist or psychiatrist, they give us this kind of questionnaires where we have to tick or we have to rate that kind of things we have to do. So these are very easy to implement and replicate, and they take very less time. But here also they need experts for scoring and interpreting this. And it can be another issue is these kind of surveys and questionnaires that can be applied either at the beginning of the task or at the end. Suppose you're studying the anxiety response of an of an individual. Now, so what we usually do is we usually take a questionnaire at the beginning of the experiment when the person just comes, takes some rest, and then we administer the questionnaire to see his anxiety level. Then we let the person do some task which will induce some kind of anxiety. And at the end, we again give him the questionnaire to see whether his anxiety level has been changed. But so these kind of surveys and questionnaires can be administered either before or after the task. But during the task, how his anxiety level is changing or varying, that kind of study we cannot do. And another issue with these surveys and questionnaires are mostly they are available in English. But for other language, I mean, other language, it is not there. So that is also an problem for this kind of surveys and self-report questionnaires. Now let's move on to the quantitative measures. So quantitative measure, first quantitative measure is the psychometric test. So these are standard scientific methods that are used to measure an individual's mental capabilities, like his skills and traits, his behavior styles, and everything. Acha, one thing is uh, we need to understand the difference between the skill and the trait. Trait is something which we cannot change, which we cannot learn, and skill is something which can be learned. Like trait is your working memory capacity. It is your trait, how much you can remember. Are you forgetful or you can remember many things? Of course, that changes with age and all, but at least at some point of time, that is trait. And the skill is something, some cognitive behavior which we can learn. Say time management, that is a skill. Then our creativity, then our problem solving ability, our decision making ability, these are skills which can be learned. And the traits are something which we cannot learn. So there are different set of tests to test a particular capability or behavior. And based on that, psychometric tests, they also fall into two major categories. So one is a cognitive tests that are used to measure brain functions or our mental processes like memory recall, attention, our information processing speed, or our judgment or anything. And then there are personality tests which test our behavior and our personality and our logical reasoning ability, those kind of things which we cannot uh, learn. So these are like some examples of the psychometric tests. So in the first one, this test is, these two tests are the tests for logical reasoning, where you have to I mean, seeing these three figures, you have to draw the fourth one. So it should be logically matching with these three. And then there are different numbers, and you have to come up with the number with this in the grid with a question mark. So these are all logical reasoning based standard psychometric tests. And then there is a remote association test. This is also a well-known psychometric test for testing the creativity. So here, this is very interesting. Here, four or three things are given which are completely unrelated, like flower, friend, and scout. So you have to come up with one single word which will match with all these three. So the answer is girl. It can be a flower girl, a girlfriend, or a girl scout. Similarly, a square, cardboard, open. So the common word can be a box. So it is remotely, these the words that are given at the left, they are remotely associated, and then you have to come up with one single word which will associate with all these three. So this is a test of creativity, how creative the person is. Then for working memory test, there are word list recall. A list of words are shown one after another, or maybe one word is shown after another, and after 1 minute time, the person is asked uh, asked to name the words which were there in the list. Or word recognition, that is also there. Once a list is shown, and after that maybe 110 words are shown, and the person has to recognize which was the words are also present in the previous list. And then similarly object recognition. So these are all standard psychometric tests. So if we want to study the human cognition, like his creativity level or his working memory level, so we have to always go with these kind of standard psychometric tests. Otherwise we cannot use stimulus, any stimulus that we want. So we have to always go for these kind of standard psychometric tests. So the advantages are, these tests, they are highly accurate, they are unbiased, they are very easy to administer, and here only the changes, experimental bias is not there because it is same for all individuals. These are standard tests and mostly manual intervention is not required. Usually these kind of tests comes in a leaflet kind of thing, and it also comes with a scoring mechanism. So when you are doing a scoring, you don't have to be a psychiatrist or psychologist. By following the rules, you can score yourself. We also see these kind of tests in internet also. There also we score. If you have scored 30 to 35, then you are uh, nature is like this. If your score is above 35, you are like that. So those kind of tests, those are standard tests, and they don't need any expert intervention. And these are time saving, and it can be applied on a larger population. These are the advantages. The greatest disadvantage is these kind of tests are not repeatable because the answers are fixed. So if we know, if we have given or taken this remote association test once, then second time I cannot use this test for testing the creativity level of that individual. So these kind of tests, these are not repeatable as the answers are fixed, and this can be always faked and manipulated very easily. And even if you know the answers, you are not going to say, yes, I know the answers, I have taken the test before and I know. So it is very easy to fake or manipulate test scores. And also there is some language or cultural barrier because these tests are also developed in English, so that is there. And they also does not give an insight about why the person is not able to execute the test. Say this working memory test, you are taking a word list recall or word recognition test, and I did not perform very well. Now it will say, yes, his my working memory capacity is low, but maybe today I'm sad, or today I'm not feeling well, or today I'm very stressed, and that's why I'm not able to concentrate. But that why is not we don't get any insight about why the person is not able to execute the test. We can just only say the person was not able to execute it. And the issue is you cannot repeat the test. So that problem is there. And real-time assessment is not possible because it takes time from starting from 10-15 minutes to some tests last till an hour. So these kind of assessment are it takes time. Now the second quantitative measure is the performance measure. Performance measure is like when the person is doing some task and we are watching his task performance, and that task performance is taken as a measure of his ability. So it is like accuracy of the answer, his response time, his time of completion of the task, error rate, etc. So these kind of performance measures are usually taken in our education system. But there also you see uh, two things can happen. Now one is I mean these kind of assessments are done for cognitive decline, cognitive impairment, for studying these kind of thing, or evaluation, or it is very useful for longitudinal analysis, like the person is going through any treatment process and how his cognitive impairments is progressing, whether it is progressing or it is decaying or delaying the impairment. That kind of study is can be done very well with this kind of test. But the limitation is, now see, two conditions might happen. Suppose me and my friend both are taking a math exam. I also scored 100 out of 100, and the person, my friend, he also scored 100 out of 100. But maybe he scored this 100 very easily because he loved maths. But for me, maths is I am fearful about maths. And for even if I scored 100, maybe I was very much stressed, and my anxiety level, my mental workload was much higher compared to him. So this actually does not uh, detect or does not it cannot assess our ability. It just saying that yes, both of them scored 100. So my anxiety level, my cognitive load, my fear, my negative emotions, those things were not considered. So it shows both of us, we have completed in same time. So our response time, our completion time of the task was same, and our score was same. So our ability are matching, equal. But it is not so. I did that with a lot of stress level, and he did it with easily. So our abilities are different, and that was not assessed. Second thing is, the on the contrary, suppose I am very good in maths, but today when I am giving exam, for some reason I am sad, or maybe there was some sad incident, or I was not well or something, I was not able to concentrate properly, and I scored 50 in the maths exam. So it shows that I'm not good in maths, and my logical reasoning and my calculating mental calculation abilities are average. But actually, I'm not average. Today, due to my context, due to my emotional state, I was not able to concentrate. That's why my abilities were not reflected well. So those are the limitations. So one specific measure is not good enough to understand the current state of the examinee. And we are here also, we are not able to infer why the person is not performing well and why the person is performing well. So that why we cannot answer. And also there is very less correlation between these measures and self-report questionnaires. So when we are say studying anxiety using a self-report questionnaire and anxiety using a standard performance based measure, there is very less correlation because it actually does not give any insight about my current mental state. Now let's move on to the third one, which is the physiological sensor based measure. This is the most reliable measure. And again, the main issue with this kind of measure is it varies a lot across individual, and also for one individual also it varies from session to session. So inter subject and inter session differences are there. Now, before going into the details of the sensor, let's just broadly or a top level view of the physiological basis of our human behavior. Now, this human reflex arc, this is a natural or neural pathway that controls any of our reflex action. Now, the reflex actions are automatic, involuntary response to any stimulus, any behavior or any stimulus. Now, the basic components of this reflex arc are: first component is the receptors or sense organs. So sense organs or sensors which are actually used to capture the data from the environment. So there is a stimulus like this apple, and then there is receptor which actually gathers data from the environment. Now these receptors, they can be different types. There can be different types of receptors. First is exteroreceptors, like our five sense organs: eye, ear, nose, tongue, skin. Then there are interoreceptor. Interoreceptors are like internal state, which senses the internal state of our organs, like emotions, our feelings. So they are called interoreceptors. And then there are proprioceptors, which senses our body movement, our joint location. So even if we close our eyes, uh, with closed eyes, we can hold our left thumb with right hand. We can do that, right? So that is due to these proprioceptors. They don't these are the proprioceptors which actually senses our body movement or our joint location in space. And in our brain, we have a map of the body, our body, in an environment, 3D environment. That map is there, and those proprioceptors, they sense our body movements. So once these signals, this any kind of sensors, they collect data, those sensory neurons then transmit these sensory informations from receptors to the central nervous system, which consists of brain and spinal cord. Now, the pathway that actually from receptors to brain or spinal cord, this pathway is called the afferent pathway. So whenever there is some sensory information, if we have to take a rapid or involuntary action, then it usually goes to spinal cord. And if we have to do a decision making or a conscious thought process is required, then it goes to brain. So either way, the path from receptors or sensors to the central nervous system is called the afferent pathway. Then in central nervous system, in the spinal cord or in the brain, some processing is done on the information that is received, and then the response is sent from the central nervous system to the effectors, which actually do the work. So this pathway is called the efferent pathway. And then we, the response is take the apple and eat it. So this is the whole physiological basis of our behavior. So whenever there is a stimulus, there is some changes, and then the efferent pathway uh, defines the response. Now, when we come to the central nervous system, then the part of the central nervous system that actually controls our unconscious or subconscious or these involuntary activities like our breathing, sweating, digestion, these are all involuntary activities, right? So, the part that controls these involuntary activities are called autonomic nervous system. Now, in autonomic nervous system, there are two branches. One is a sympathetic branch and the other one is a parasympathetic branch. So when our body, or when there is a stimulus and our body sense any threat, then this sympathetic branch, it creates a response so that it prepares our body for any potential danger. So suppose if our stress level, if the body or if our autonomic nervous system sense that there is a reason for increasing the anxiety, so what it will do, it will instruct the sympathetic branch of the ANS to take over, and then it will prepare the body. How? It will increase the breathing rate. It will so that our oxygen, more oxygen level, more oxygen is uh, enters into our body. It will increase our heart rate so that more blood is pumped. So those kind of, it will dilate the pupil so that more light can enter and we can see better. So it will prepare the body. So sympathetic branch, it manages the fight or flight responses. So those responses are like very fast response, increased heart rate, increased breathing rate, dilate people, and so on. And then there is parasympathetic branch. So when the threat is removed, or when the body sense that now it can calm down, so then it brings the body, the parasympathetic branch, it brings the body to calmness, and then it permits the rest and digest response. So it reduces the heartbeat, muscles relax, pupils contracts, and so this comes to the initial homeostasis of the body. So if we want to uh, study some of the threat responses, then we have to use sensors which are best, I mean, sensors which are taken over by sympathetic branch, like increased heart rate, breathing rate, pupil dilation. And if we want to see the rest and digest kind of thing, then we have to uh, check the parasympathetic branch of the ANS. So now let's come to the physiological sensors. So there are different kind of physiological sensors. So the sensors can be broadly classified into two categories. One is brain-based measurements and another is non-brain-based measurements. So brain is the main thing. So everything happens, or every decision making and everything that happens in brain. So these are the only direct measures. Any sympathetic or parasympathetic measures that we take, like heart rate or pupil dilation or breathing rate, those are all secondary measures. Those are all the responses that were created by the brain and our body. Okay, so the main brain based imaging technique that is used is fMRI, which is a non-invasive imaging technique that measures the brain activity by detecting the changes in the blood flow. So these are very accurate and have very good uh, spatial resolution. So at which location of brain there is a change, that can be detected very well, but it has a very low temporal resolution. So at what time that changes happen, that we cannot say from fMRI accurately, but it has a very good spatial resolution. So but yeah, I mean, this is very accurate, but it is expensive, and it is bulky, and it is mostly used for medical use cases, and in out of the lab experiments or in out of the lab scenarios, we cannot use this kind of systems. Then there is positron emission tomography or PET scans, where some radioactive material is introduced, and they study that position of this uh, electron movement. So that is there. This is also accurate, but this is also again very expensive, bulky, and difficult to handle. Then somehow lower complexity level device is FNIR. This also study the oxygenated blood in flow in the head, and that is FNIR. And the most widely used device that is for human sensing is EEG, or electroencephalography, which studies or which records the electrical uh, signal that is generated in the brain. Like in our heart, ECG studies the electrical signal that is generated in the heart. Similarly, EEG records the electrical signals that is generated in our brain. So there are many high resolution EEG devices like 64 lead devices. So there are different locations, and these locations are also fixed across our skull. And so there different 1020 system is there, 2020 system is there, 1010 system is there. So these are different nomenclatures that are used for placing these electrodes. So these places are also fixed in on the skull, and these are medical grade devices. Also nowadays there are certain off the shelf devices like Muse. This is what, this one is Muse, this one is Emotive. These are very easy to use and can be used in out of the lab scenarios also. And then there are various non-brain measures like galvanic skin response, which studies the variation in the conductance level in the um, skin. So when there is a stress, when the stress level increases, or we ti- I mean tend to sweat, that changes the conductivity of our skin. So the current that is passed from using these two electrodes, so the conductivity offered in a circuit, that will also change. Then there are eye trackers. Either it can be a wearable type of eye tracker, or some eye tracker that can be placed in below the screen. Then there are PPG, photoplethysmography, which can be used to study our heart rate, our oxygen saturation level. Then ECG. Facial analysis is also important and very widely used today. Then speech sensors are there. EMG, that is the muscle study, I mean the sensors that are used for muscle activation and muscle deactivation, those are it. And apart from that, there are other sensors like skin temperature, blood glucose level, body gesture, posture like Kinect camera and all, from motion data. And then there is respiration rate camera, and of course smartphone and smartwatch is also there today. So the basic steps, if we think, so there are some steps. So based on the thing that we want to measure, we have to choose the appropriate sensor to monitor and capture the user behavior. Then we have to collect the stored and pre-processed collected information through data analytics techniques. Then we have to extract the features in a way that differentiate that behavior. So if you want to study, say, stress level from GSR, we have to come up with some of the features which are in the GSR, which are indicative of stress. So we have to identify or extract those features, and then we have to develop a reasoning or classification algorithm to infer the behavior from the sensor data. So the technical challenges that we face is the heterogeneity and variability in how data are generated and used. So there are different devices, the accuracy and the scale factors and everything of these devices, the sampling frequency are different. So that heterogeneity and variability is always there in the data. Then, as I was mentioning, the uncertainty and incomplete nature of the observations, because human subjectivity is there. So intersection and intrasection, within a section also it varies. So those are there. And since we are handling human data, so privacy and ethical issues are also important. So these are some of the technical challenges that we face always in case of human behavior and cognition sensing. So human behavior sensing application areas also can be broadly classified into two categories. One is the medical use cases like mental health and mental well-being, early detection of various types of diseases, then health monitoring and elderly care, which is also important, rehabilitation, and these are like the longitudinal, we have to do a longitudinal study to see how these treatments are going, how the rehabilitation plan is working, and maybe based on the progress we have to change the rehabilitation plan. And then personalized treatment plan, deciding those things. These are the medical use cases. Non Some of the non medical use cases, the most important one is learning. So for learning design, I mean content design, student attention, student cognitive load, mental workload detection, those kind of thing, those kind of studies are done using these human sensors. Then there is neuromarketing, which is also another very upcoming and important application area, where, and I mean there are in last few years there are some companies, they have used this neuromarketing. Earlier they used to, before any product launch or anything, they used to take a survey. They used to select a group of target audience, and they used to do a survey and see how they are performing. But now they have seen that because most of our decisions that we take, those are we take that unconsciously. So they have seen that these kind of surveys, in most of the cases, in 67 70% cases, the products that they launch, they fail. So nowadays they are doing these neuroscience based marketing. So before launching they do different kind of eye tracker or EEG based studies to select the product design, and everything. So Coke, PepsiCo, Hyundai, they use this kind of marketing today before launching any new product. Then there is UI design, then content evaluation, brain computer interface, and human robot interface, that is also another thing. And then there is cognitive ability test, which are used in companies and industries for HR assessments and all. Now let's move on to some of the works that we are doing in TCS. So I will mostly focus on two papers that we did recently. So one was detecting differential dermal potential, a new paradigm for measuring cognitive load. So cognitive load or mental workload, it is the amount of mental resources that is required to execute any task. So some amount of cognitive load, if it is too low, then your capability or your ability is much higher compared to the task demand. So that will create boredom. And if your cognitive load is too high, that means the challenge or the task demand is much higher compared to your capability, and that will result in stress. So an optimum amount of cognitive load has to be maintained, and that is very different. Otherwise it will either result in boredom or it will result in stress or anxiety. So optimum amount is required for completing the task successfully, and the task performance is also negatively affected as the cognitive load increases. So high CL for prolonged period, that results in stress and anxiety, depression, and continuous measurement for CL is important in real time. Now for measuring this, we have used electrodermal activity or GSR. So in GSR, there are two types, either that can be an exosomatic or endosomatic. So exosomatic is the standard GSR, or the lie detector thing that we use. So there we send current through two fingers, and we measure the conductivity offered by the skin. And when the person is stressed, his skin conductance level changes and the current also changes. So that variation is studied to see the amount of anxiety level. And then there is another approach which is called endosomatic, where no current is uh, passed. We just measure the potential difference between the two fingers or two electrodes. So when we use exosomatic, one is the most widely used one, because there are many of the shelf exosomatic GSR devices that are available in market. So most of the time the researchers, they use exosomatic, but the current actually that is passed through our fingers, though it is a very low current, 1 microampere or 5 microampere kind of current, but that current actually disrupt our body equilibrium. So we might not get actual state of our body. So that's why we thought that we will use endosomatic approach for measuring the cognitive load. So the methodology that we have adapted, this is the device. You can see in the right, this white box, and there are 4 channels. So 4 channels can be connected to 2 hands and 2 legs. So these electrodes are connected to 2 hands. So it is one, I mean, through these electrodes current is passed, and the stimulus is shown in the screen, computer screen. The stimulus that we used were a mental addition task of 2 different difficulty levels to impart high and low cognitive load. And we measured the GSR as well as DDP, that is the endosomatic potential difference. And NASA TLX questionnaire, this is a grand gold standard for cognitive load measurement, gold standard questionnaire. So we have used that as a ground truth for perceived CL level. So then we, as I said, we selected the most, we generated the features, then we selected the most significant features for GSR and DTP signal, and we created a model for load classification. So we have tried 3-class and hierarchical classification both. So in hierarchical classification, first the signal was classified between rest and load condition, and if a load condition is detected, then we further classified that in low or high load. So this kind of hierarchical approach we took. So so I will not go into the details of this. So these were the data collection protocol that we use. So uh, and in between we had to, so these 45 minutes were as the baseline, and then a task was introduced, then again relax, and then again task. So in between you have to always give a break so that the person's elevated mental state comes down to the baseline again. So these relaxation periods are given for that purpose. And then we collected data in 2 different cohorts. In one cohort, cohort 1, we collected both GSR and DTP data. And in cohort 2, we collected only DTP data. So we just wanted to see whether the presence or absence of GSR makes any difference. So these are some of the results. So you can see this is the potential difference signal from low and high load. So you can see there are distinct, the natures are completely different when the cognitive load increases. So the classification results for using the hierarchical approach, we saw that when we used the cohort 2 data, that is the only DDP data without GSR signal, when we used that, we achieved maximum accuracy for load versus rest condition as well as for low versus high condition. So in both the cases, the cohort 2, when we trained the model on cohort 2 data, that gave a better accuracy, and DDP accuracy was much higher compared to that obtained using the GSR only. So the conclusion was the DTP signal can be used for detection and classification of cognitive load. We achieved an accuracy of 80% for low versus rest versus load and 72% for low versus high. And we achieved significant improvement compared to the traditional GSR based approach. And we also observed that the presence of GSR during the simultaneous recording that actually dampen the DTP signal, particularly when the differentiating between low and high load condition. So if you see, when we tested using a model which is trained on cohort 2 data, we got very high accuracy for rest versus load condition. And when we used DDP signal from cohort 1, that time this accuracy was 74. So because in DDP, the GSR signal, GSR device was also connected. So GSR, how much, though we say that it sends a low amount of current, but it actually changes our body potentials. The second work that we have done is a GSR based generic stress prediction system. It was accepted in UBCOM 2023. So here also we generated how much time I have? Uh,
Madam, office, this is up to 9. Okay, so you
ah,
can, you please continue.
okay, okay, okay. So in this one, the prediction and classification of stress was important, and we took a questionnaire and the physiological signal, since we wanted to see the parasympathetic sympathetic nervous system activity. So GSR is a very good indicator of that. Plus breathing rate and these things are also very good indicators. So we chose our sensors like GSR, ECG, and breathing rate, and we got a person specific model we thought was working better. But then based on that, we used only GSR out of these, and because the stress response actually results in sweat gland activity, which can be very well recorded by GSR. So that was one reason. Another reason is there are many various variable and off the shelf devices that are available in the market, and also there are very many public GSR datasets available for stress analysis. So we used four different types of publicly available datasets like VSAT dataset, S-test, affective road, and DS3 dataset. So if out of these four, these first three datasets, they used Empatica E4 device, and the last one they used a shimmer device. So the sampling frequency of Empatica was 4 hertz, and for shimmer it was 32 hertz. So for the VSAT, their testing condition was stress versus no stress, and they used TSST protocol, which is a standard uh, anxiety invoking protocol. There the person has to do a mental arithmetic task, and then he has to go through a extempore speech about his own weaknesses and strength in front of a panel. So that was there. Then there is S-test that also tested, the testing condition was stress versus no stress, but the experiment or the stimulus that used were mental arithmetic. For affective road, they also checked stress versus no stress for CT and highway driving. And DS3 also used TSS3. So these are the data, number of subjects that were available in each of these four. So in total, we had 60 subjects data, and we divided them into 52 and to 8 for train and test. And for only tested for building the model, and for testing the our proposed model on unseen data, we used two more data set, that is unseen TSST, that was in-house in TCS. We collected 5 people's data using shimmer, using TSST protocol. And then there is another public data set, which is UBFC5, is an open data set that used Empatica E4, and there were 56 subjects of data for mental arithmetic and speech. So in for all these four, first we normalized these data sets, and then we merged, and then we converted the data into an uniform sampling rate. Then we selected the good data, uh, and then calculated the feature, then feature selection, and then we created the model. And for unseen data also, we normalized it and calculated the discriminating features that we uh, uh, obtained after this feature selection. Sorry.
Madam, you please continue.
Okay. Okay. So yeah, and so this is a sample GSR data for baseline and task. You can see when in the task period the GSR level elevates. So task is the this orange one, and baseline is the blue one, and these are some of the noise. So these kind of high frequency noises are sometimes we observe in GSR data. So that noises were cleaned. So these are some of the results. So we created the stress versus no stress classification. We used various kind of classifiers like GBT, RF, ADA boost, and we saw that for GBT, the sensitivity was quite high, whereas for RF and ADA boost, the specificity was high. So we thought that we should do a voting kind of thing. So we tried two approaches, voting one and voting two. In voting one, we gave equal weightage to all these all three, and we scaled them to the accuracy values. And in voting 2 we did a grid search based kind of thing, and the total weight, so that we divided the weights in between GBT, RF and ADA boost, and so that the sum of the weights will be 1. And final weights that we obtained for GBT, RF and ADA boost was zero point 0.1, 0.3 and 0.6. Now with that we got around 89% accuracy with a very good sensitivity and specificity. Then we use this voting 2 model for for testing the unseen data. And for unseen TSST, we got 84% accuracy. And for UBFC5, we got 92% accuracy, which is quite high. Then we drill down into this unseen TSST data. Actually, for UBFC5, there were 56% data. So we thought unseen TSST, we have 5. So we will drill down and see why it is giving relatively less accuracy. So in unseen TSST, we had 5 subjects data, and there were 2 types of tasks for each subject. So we saw that for subject 2 maths and subject 4 maths, the accuracies were pretty low. So accuracy was 55 and 45. So then we went to their feedback thing, that is the NASA TLX, or the stress. For stress, we got a questionnaire that we used was STAI questionnaire. So we checked the STAI questionnaire, and we saw that these persons were not at all stressed. So maybe for these 2 subjects, maths was an easy thing and they were not at all stressed. That's why there were very less variation in GSR for between task and baseline. And also that's why our model was not able to identify uh, between the task level and the stress level. So that's why the accuracy was pretty low for these 2 subjects. And then we also checked the accuracy of our model with with these public data sets. And these are the we saw that the proposed one, this unseen TSST with all of the public data sets, and our proposed model was giving much higher accuracy for out of all this. So in conclusion, we can say that we developed a person and stressor independent generic stress model. We identified the most important or most significant GSR features that can discriminate the stress level across participants and tasks. And the application of the model works very well with completely unseen data. and test accuracy were around 89% for 80-20 split, and it was completely unseen data, it was 84% and 92%. So yeah, with so these were some of the mm, tasks or the things, the works that we are doing in TSCS. Apart from this, we are also working on cognitive load, attention, and those kind of things. So yeah, with that, I'll stop. And if you have any questions, anything in mind.
Actually, there are some questions in the
Yeah.
chat section. So the first question is from Ranjita Chaudhary, Madam Ranjita Chaudhary. The question is mental health define a state of brain? Can you define the term mental health state of which component?
Yes, mental health is a kind of mental state, because mental health is how well you mentally are. So you should be happy, you should be stress less, there should not be any anxiety. So yes, it is a kind of mental state, and health term is used because it signifies well-being. So mental well-being or mental health, yeah, but it is a kind of mental state, a part of mental state. Mental state also include other factors like emotion, like our cognition. Those are also a type of mental state, whether you are excited or whether you are not. So that is there. Some emotions are positive emotions, like we are happy, we are excited, we are overjoyed. Those are positive emotions, those are also mental state, but those are those states, they cause mental well being. And there are certain states or negative emotions or negative states that i mean reduce or that affect our mental health. So yes, health is a part of mental state.
Okay,
Hello,
ma'am. The
madam.
next
I have
question is
one
from
question.
Yeah.
Uh, so, regarding cognitive load measurement, you have told GSR signal and DDP signal. So, I
Hmm.
have to some extent idea about GSR signal, but how the DDP signal data is collected. Uh, if you put some light about the DDP signal,
Okay, so
it
for
will be.
so the main thing is for GSR signals, there are many off-the-shelf devices that are available, like Empatica, Shimmer, and Analog Watch, and different other few other watches are also there, which can be used. But DDP, it is, there is no off-the-shelf device that you can get from market. But since it only, most of the research teams, those who work on DTP signals, they usually build their own device. And since it only measures the potential difference, so you just need an amplifier, and also this is very safe, and usually they design their own device. For this particular work, in Jadavpur University instrumentation department, Professor Ratna Ghosh, they have designed a device, DDP device. So we collaborated with them,
Acha,
and we used their device for decoding the data.
acha, for data
So
collection.
if you want to work, you can contact with her. She is very helpful, and she is very energetic, and she will definitely help you or lend you a device for data collection.
Thank you, madam. Thank you for your information.
ma'am. There are some questions in the chat section. Dr. Subro Shanti Ranjan Thakur has asked that data collection about patient you have mentioned. Are you connected to any hospital? Means
Yes,
is
yes,
that data
yes.
connected from hospital
Yes,
directly?
yes, if you want to collect patient data, you will definitely have to collaborate with hospitals. Otherwise, we are not entitled and we are not supposed to collect any patient data. This will go against ethics and I mean nowadays even when we go for any paper publication and all, they always ask for these kind of things. Earlier
Right.
it was not like that, but now they always ask
The
if you have used human data, how you collected it, everything you have to mention.
data should be
And
verified by the ethics committee, right?
yes, yes, and the data, we are not supposed to collect any patient data.
Right.
Only medical practitioners can collect data. Usually we collaborate with hospitals. They collect the data, they anonymize it, and then they give it to us. And that too, not everyone. We have to make an agreement that only these
Hmm.
people, they will handle the
Well,
data. Only they can I mean the name that is there in the agreement, only those people can handle the data. Medical data, human data is very crucial. And these cognitive load and stress and all these cognition related thing, when we collect data, sometimes we do that within TCS also. But there also, before collecting data, there is an ethics committee within our TCS. So we have to take their approval, and there is a formal process for taking the approval, and legals also, they also approve that yes, we can take that. Then we collect the data. And also the person who is collecting, in most of the cases we also try to anonymize the data. And yes, obviously the person who is handling, he knows, but we always anonymize it, and then we give the data to our team members. And after that, when we I mean discuss amongst ourselves, we never take the names, we always say subject 1, subject 2, like that. So yeah, those kind of thing you have to follow.
okay, ma'am. Madam Ranjita Chaudhary, can you please unmute yourself and elaborate your question, if possible? So, ma'am has asked that is it mental well-being or brain health well-being?
No, it is mental well-being. Emotion is a part of mental well-being.
Okay, ma'am.
Brain is the organ, but the thought process or everything that is there, that is called mental. So yeah, mental well-being.
Participant, any more question? If there is, you can unmute yourself and ask directly to ma'am, or you can put in the chat box. So, ma'am, I think there are no more questions. Deep Saman sir, can you please conclude this session?
Yes, sure, sir. At the outset, I deem it my duty to express deep sense of gratitude to our distinguished guest, Dr. Debatri Chatterjee, for gracing this program with her presence and for sharing such profound insights with us. Madam, your words have indeed enlightened our minds and enriched our understanding. With these
Thank you
words,
so
I
much.
with these words, I once again extend my deepest gratitude to everyone present here. May the knowledge and inspiration gained today continue to guide us in our professional and personal journeys. So thank you all. So this is the end of session 8, day 4.
Thank you. Thank you so much.
Thank you.
Thank you, participant. See you tomorrow.